Carbon-14 has a half-life of 5,750 years. A sample with 17% of its original carbon-14 is how old? Round off your answer to the nearest year. Okay, so the amount of carbon-14 left after t years will be the initial amount times e to the RT. Let's find R using the half-life. So we know that after 5,750 years, the amount will be half as much as we started off with. Well, it's 1/2 of the initial amount. So if we divide both sides of this equation by the initial amount, we get that e to the 5,750 times r is equal to 1/2. The a naughts cancel out here. And so to solve for r, we can simply take the natural log of both sides of this equation, or equivalently, write this in logarithmic form. The natural log of e to the 5,750r is 5,750 times r. That'll be the natural log of 1/2. 1/2 is 0.5, so it's the natural log of 0.5 as well. And now dividing by 5,750, we get that r is equal to the natural log of 0.5 divided by 5,750. So we have found the decay rate, R, for carbon-14. And armed with that, we can solve any carbon-14 problem. In this case, they want to know how old is the sample if 17% of the original amount is still present. So going back to our decay equation for carbon-14, now we know the rate R. They say the sample has 17%, that's 0.17 times the initial amount. And if I divide both sides by the initial amount A naught, we don't know what it is, and we don't even care. It cancels from both sides of the equation, so we're left with e to the RT equals 0.17. And we know what R is, so in fact this is e to the natural log of 0.5 divided by 5,750 is equal to 0.17. That's R times T. There's the times T. So now, if we take the natural log of both sides, or write this in logarithmic form either way, the natural log of e to any power is the power. So we end up with the natural log of 0.5 divided by 5,750 times t is equal to the natural log of 0.17. That's the natural log here of 0.5 divided by 5,750 all times t. Therefore, solving for t, we get that t is equal to the reciprocal of this, so it's 5,750 times the natural log of 0.17, all divided by the natural log of 0.5. Let's calculate this, see how old that sample is. So we have 0.17 0.17. Take the natural log of that and multiply that times 5750. Then divide that by the natural log of 0.5. And so I get the t here is equal to 14,699.261 years. In other words, that's about 14,699 years old. That's the age of the sample, rounded off to the nearest year, according to this carbon-14 test.